Hi, Chem Peeps. Let's talk about unit conversion, and we're going to start with metric first. You can see I have a picture of the metric relationships as far as prefixes and standard units. So here in the middle, we just have a value of 1. That is just for our regular units that we use that have no prefixes in front of them. In fact, we could write it 1 times 10 to the 0 if we wanted to keep it the same as everything else. Everything below that 1 are smaller prefixes for a unit. And everything above that standard unit are larger. Now, how do we use these relationships in unit conversion? Well, I'm just going to jump to step 2 here first because I want to show you how to find the relationship between two units. Let's say that I'm going to go from centi to kilo. Let's first look. The kilo is going to be the larger unit. So the larger unit is going to get a value of 1. So what does 1 kilometer equal in a centimeter? Well, or in centimeters. So a centimeter is going to be the difference between the unit exponents. So I have an exponent of -2 and an exponent of 3. So I'm going to take 3 minus a -2, which will be 5. So 1 times 10 to the 5th centimeters is equal to 1 kilometer. And that makes sense because the kilo is larger. It's going to take a lot of little units to equal that one bigger unit. So let's use these in some examples. Okay, in this problem, we're going to go from 65 kilograms to milligrams. And right away, I can see this is the larger unit and milligrams is the smaller. So therefore, 1 kilogram, since it's the larger, it gets the value of 1, will equal how many milligrams? Well, if I subtract the units, it's going to be 3 minus a -3, which means it's a 6 milligrams. So we're going to use the 6. So you can see that I've already done that. I've also put this equivalency, 1 kilogram equals 1 times 10 to the positive 6 milligrams, set up in the problem in such a way. First of all, we write down our given. This is what is given to us in the problem, right here. Now, I'm going to multiply by the equivalency of these two units such that the given kilograms will cross out with the kilogram in the equivalency. So this is our equivalency. And I put the kilogram in the denominator right here so that it'll cross out with the kilogram in the numerator. And then, of course, in the numerator, I have the milligram. So how do I solve this to get the final answer? On my calculator, I'm going to take 65 times everything on the numerator, 1 times 10 to the 6th, and then divide by the denominator, 1. And I am going to get 6.5 times 10 to the 7th milligrams. And if you don't want to use scientific notation, it'd be 6, 5, and 6 zeros milligram. Let's try another problem. Okay, in this problem set, we're going to go from 20 milliliters to picoliters, milliliters to picoliters. Milli is actually, they're both small prefixes, but milli is the larger of the two. So you can see that I gave it a value of 1. How did I get -9? Well, if I look at the exponents for milli and pica, it's going to be a -3 for the milli minus a -12 for the pica. And when I subtract that, I get the -9. Now, to solve the problem, we multiply across the numerator. So we're going to take 20 times 1 times 10 to the -9th and divide by 1. And notice when we divide, the milliliters units cross out, and our final answer is going to be 2 times 10 to the -8th picaliters. Okay, let's try another one. I threw this one in for an important reason. I always make my students learn this relationship. Oops, and I forgot my cube on here. Let's put that on there. So 1 milliliter is equal to 1 centimeter cubed. And that's a pretty easy thing to remember. But what's really important about this relationship, it gives us a relationship between volume and length. And we can use that in many ways down the road. So let's convert 50 milliliters to centimeters cubed. It's pretty easy. We write our given down. So that's the first thing that we do. We've written the given down. Then we're going to multiply by the equivalency in such a way that the unit in the equivalency crosses out with the given unit. So they're on opposite sides of the division line. And of course, if I take 50 times 1 divided by 1, I get 50, but now my unit is in centimeters cubed. Good relationship to remember. Let's try another set. Okay, here we're going from a metric unit of a pound to kilograms, which is a metric unit. I looked in the back of my chemistry book, or I can Google it online. The relationship between a pound and a gram is 1 pound is equal to 2.54 grams. 55 pounds is my given. So let's go ahead and write down our given. That's the first thing that you do. So the given is 55 pounds. I want to use this equivalency here to get from pounds to grams. And notice that pound and pound will divide out because they're on opposite signs. Now, I'm in the unit of gram, but the problem is asking for kilograms. So what is the relationship between a kilogram and a gram? Well, the kilogram is the larger unit. So notice I put a value of 1 there. How did I get 10 to the 3 grams? Well, kilo has an exponent of 3. The gram is the standard unit. It has no prefix, so it has a unit or an exponent of 0. So the difference in those is 3. So how do we solve this problem? Well, we're going to multiply across the numerator first. So I'm going to take 55 times 2.54 times 1. Now, to that answer, divide by the denominator. So we got two numbers to divide by, 1 and 1 times 10 to the third. And my calculator answer is going to be, it's going to say 1.397 times 10 to the minus 1 if you are in scientific. If you're not, it's going to be 0.1397. And I have two beginning sig figs, so I'm going to keep these two. So it's going to become 0.14, and my unit is what didn't cross out, which is kilograms. And you can see here I didn't do it, but grams cross out with grams because they're on opposite sides. Let's look at another problem. Okay, this is a much harder problem. The given has a numerator and a denominator for units, and our answer is going to have likewise. Let's deal with one unit at a time. So you can see my beginning given. Oops, I didn't include that in the problem set. I forgot my denominator here, per day. Oh my. Trying to delete this. Okay, here we go. So the problem set has per day. So let's look at how I came up with this setup. First of all, this is our given, so let's write it. And I'm going to just rewrite it down below as we talk through this. So we have 22 kilometers squared over days. Let's start with kilometer. I want to go from kilometer to millimeter, but they have to be squared. Our conversion chart is not squared, but we'll deal with that. Let's just find the regular relationship between them. So kilometer is starting in the numerator, so we want to put kilometer in the denominator. And then up here we want to put millimeter. What is the relationship between these two? Well, kilo is the larger unit, so it's going to have a value of 1. Millimeter, if I take the exponents, is going to be 3 minus a negative 3, which is going to be 6. So that's how I got the 6 there. So I'm going to just go ahead and erase that now and write in the 6, and they need to be squared. When you square the unit, you must square the value too. So I'm going to square all of this. Okay, so when I square all of that, I'm going to change what it's actually going to look like. First of all, 1 times 1 is going to be 1, but the unit then becomes squared. when we multiply, or when we square exponents, we multiply them. So I'm going to take 2 times 6. That's going to give me 12. So my final answer up here on the top is going to be 12 millimeters squared. And notice that the kilometers squared and the kilometers cross out. We have just taken care of the numerator's unit because I've gone from kilometers squared to millimeters squared. But I'm not going to be done. I need to continue on in this problem set because I have to take care of the denominator unit, which is the day. That's just going to come from your experience. So one day has how many hours? Well, we know there's 24 hours. Notice in this problem that I put the one day on top so that it crosses out with the day in the given problem. And so I'm now in hours, but I'm not done because I want my final answer to be in seconds. So let's go to the next thing I know. For every 1 hour, there are 60 minutes. And notice hour crosses out with hour, and we are not done. We got to get to second. So 1 minute has 60 seconds. And again, the unit minute crosses out with the unit minute. I know this problem is set up properly because if we just do a check here, I have millimeter squared not crossed out, and I have second not crossed out. Millimeter squared is in the numerator, second is in the denominator. So to solve this problem, I'm going to take my calculator and I'm going to multiply across the numerator. So I'm going to take 22 times 1 times 10 to the 12th times 1 times 1 times 1. To that answer, I am going to divide it by 1. I'm going to divide it by 24. I'm going to divide it again by 60, and finally 60 again. And our final answer is going to be 2.5 times 10 to the 8th, and don't forget your units, millimeters squared per second. And that is how you do unit conversions. Very handy in chemistry. Check me out on TikTok at Chemchats, and I will see you next time.